Good morning, good afternoon, or good evening, ladies and gentlemen. Welcome back to Unit 9. Yesterday we talked about Lesson 9.1, which is all about energy. And if you need to go back and review that lesson, that would be a great idea because we're going to be using the stuff that we talked about yesterday as we move forward into Lesson 9.2, called Work and Power. Now, I bet everybody out there knows what work and power mean, but do you know what they mean in a physics sense? Well, that's what we're going to find out today. So let's start with work. In the simplest definition, work is a force acting through a distance. That's what it says right there. Now, we abbreviate work with a capital W. Work is closely connected to energy because if you do a certain amount of work, that tells you how much energy you have caused to change forms or to move from one place to another. So the amount of work that you do is equal to the amount of energy that you transform. We measure work using the same units that we use for energy, which are joules. Again, go back and review Unit 9.1 if you do not remember what joules are. So work and energy are both measured in joules because work is just a measure of how much energy you have transformed. I know, I've said it 3 times already. Make sure you get that important point. Work is calculated by multiplying a force by a distance. So if you're using a force to, say, push a box across the floor, you take the amount of force that you're using in newtons and you multiply it by the distance that the box travels in meters, and those two numbers multiplied together will calculate the work. Remember, force and excuse me, edit that out. Remember, work is measured in joules, and force and distance are measured in newtons and meters, and a newton meter is also the same as a joule. Now, because we have this formula, we can pop it into this triangle here. Work is equal to force times distance, and this gives us 3 formulas for the price of 1. So let's take a look at our first word problem. How much work does Rosanna do if she uses 50 newtons of force to push a lawnmower 15 meters? We'll use the guess method to solve this problem. Start off with the amount of force, which is given to be 50 newtons, and the distance traveled is 15 meters. What are we trying to solve for? Work. So what equation can we use to solve for work? Well, work is equal to force times distance. Substituting in the numbers that we know, replace 50 newtons for force and 15 meters for distance. And then all you have to do is grab your trusty calculator, or maybe you can do this in your head. Multiply 50 times 15, and the answer is 750. And a newton times a meter gives you a joule. So Rosanna did 750 joules of work pushing that lawnmower 15 meters. Now here's an important little catch. If nothing moves, then no work is being done, at least not by the physics definition. So you can stand here and push against a wall all day. But if you do not move the wall, then by the physics definition, you haven't done any work. Now you will probably get very tired and feel like you have done work, but no work has been done against the wall if the wall doesn't move. Remember, I said that work is equal to the amount of energy that you have transformed. So if you lift a box straight up, for example, you give that box potential energy. You give it energy that it did not have before. And the amount of potential energy that you give the box is exactly equal to the amount of work that you do lifting the box. They're the same. So next, let's talk about power. Power, which is abbreviated by a capital P, is the rate at which work is done. It's how fast you do a certain amount of work. We measure power using the unit watts, W-A-T-T, and we abbreviate watts with a capital W. Well, that could be confusing because remember, we also abbreviate work with a capital W. So if you see a capital W, how do you know if it stands for work or watts? Well, I'll tell you. If you see the W after a number like 60W, then it probably stands for watts. If you see the number at the beginning of a formula like W equals F times D, then it probably stands for work. A watt is equal to a joule per second. So, for example, a 60-watt light bulb is transforming 60 joules of energy every second from electrical energy into heat and light. Power is equal to work divided by time. So once again, we can put a formula in a triangle. P is equal to W divided by T. And once again, we can rearrange this formula 3 different ways using this triangle. So let's take a look at our next word problem. If Eric does 100 joules of work in 8 seconds, how much power does Eric develop? Well, let's see. What information were we given? We were given that Eric does 100 joules of work, so the W here stands for work, in 8 seconds. What is it we want to know? We want to know how much power Eric produces. The equation that we'll use is power is equal to work divided by time. Now substitute. We replace the work with 100 joules, and we replace the T, 8 seconds. And then you grab your calculator and you say 100 divided by 8, and your calculator will tell you the answer is 12.5. Joules per second is equal to watts. So the power that Eric produced was 12.5 watts. How much work can a 40-watt motor do in 30 seconds? What information are we given? We're told that the power output of the motor is 40 watts, so P equals 40 watts. W stands for watts. And we're told that the time is 30 seconds, so T equals 30 seconds. What are we trying to solve for? We're trying to solve for the amount of work. How do we get work if we know power and time? Looking at our triangle, power and time are side by side. So we have to say work is equal to power times time. Now we substitute. We replace P with 40 watts. And we replace T with 30 seconds. Have your calculator and multiply those numbers together, or if you can do it in your head, that's fine too. 40 times 30 is going to be 1,200. Now a watt times a second is a joule. Why is that? It's because a watt, if you remember, is equal to a joule per second. So we could scratch out that W and change it to J over S, and then the S's would cancel out, and we'd be left with just joules. So that is going to be the end of lesson 9.2. Folks, as always, I want to thank you so very much for joining me today. I hope you're doing very well. I hope you're taking care of yourselves. Please hop on over to Google Classroom and I'll have a short assignment for you to do. If you have any questions, please don't hesitate to let me know. In the meantime, keep washing your hands, and I will talk to you tomorrow for lesson 9.3, Thermal Energy. Take care. Bye.